Hello everyone and welcome back. So let's try this problem right here. It's not quite as difficult as some of our other ones, but it's still a good basic frame example. What we have here is two multi-force members, and they're attached with a pin connection. We want to figure out, well, what are the forces at C, B, and A? So what do we do? Well, the first thing we do is we draw a free body diagram. So I take the sum of the force, that we have BX, BY, and a BX. Okay. There will also be a CY and a CX. And terror of terrors, we can't actually solve because we don't have enough equations. We've got four unknowns, but only 3 equilibrium equations. So there's various things that you can do right here. You can panic and cry, or you can realize that you actually know a little bit more than you realized. For example, I'm going to take the sum of the modes around point C. I can't solve for everything, but I can solve for a little bit. And so sum of the modes around point C, well, I'm going to have quite a few things causing a moment. Luckily for me, this force is perpendicular to the surface, which doesn't make things too terrible. And so the sum of the modes around point C is going to be caused by Bx times this distance, which is going to be 8. How did I get that? It's actually just like a slope triangle. This is 10, this is 6, and if you use your Pythagorean theorem, you'll see that this is 8. Nice little trick there. And so I get, okay, Bx times 8, and that is counterclockwise, so counterclockwise is positive. And then I have this 2 kip load, which is going to be turning me clockwise. Actually, that's counterclockwise too. Yes. So, plus 2 times 3. Why did I do just a distance of 3? Why am I doing distance from B? It's because I only need that horizontal distance, because it's a vertical force. And then this last one where you're like, I need to break up the components, it's terrible. You actually don't, because you already know what the perpendicular distance is. And so this force is perpendicular to this surface, so you already know the perpendicular distance. You don't actually have to do anything crazy. And this one also will turn it counterclockwise, which means, as usual, I drew it in the wrong direction. One of these days, I'm going to get it right, and I'm going to faint right then and there. So Bx will be equal to -2, -2 kip. Okay, so yes. So let me go ahead and draw that in the correct direction, and I'll erase a whole bunch of my stuff right here. Okay, that's good. Let's get rid of that. C1. And that's going to be 2 kips. Okay. Fantastic. Now, I actually can solve one more of my equations. One of my other equations only has one unknown. I can't solve for the CY and BY, but I can still solve for a lot. So, sum of the forces in the x direction. If you look at that, I've only got one unknown in the x direction, which means I should be able to solve for that. It's going to be equal to 4. Now here's the difficult thing. What is this for? What direction is it going? That's not going to be super easy. You're going to have to do some triangles here to figure it out. But if you look at this triangle, what you should probably hopefully notice is that it looks like the opposite of this triangle. So while this one has a bottom of 6 and a side of 8, this one will have a bottom of 8 and a side of 6. For perpendicular lines, the slope of one is always the inverse of the slope of the other. Okay, the slope of one is always the inverse of the slope of the other, and the negative inverse to be exact. So use that to help yourself if you don't know that. Okay, so I got 4, and I need to have the horizontal component, so 8 over the hypotenuse, which is 10. So that'll be 4/5. Okay. Plus Cx minus 2, and that's going to be equal to 0. So when I solve that, what do I get? Well, let's try figuring it out. Calculator. 2 minus 4 times 0.8 equals -1.2, which means I drew it in the wrong direction. Okay, so I can redraw this one and say that that's 1.2 going that way. So what you see here is that we actually could solve some of it, just not all of it. CY and BY, they're still a mystery to us. but we will solve them eventually. Now, with that in mind, let's jump in and see what else we can solve. Like, for example, if I look at this bottom member right here, I'll do that one first. I think it's going to give me a lot of the information I need. How do I know that? I'm a teacher. I've taught this and done this a lot, so some of this is going to be something you get better as you go. So it has a length of 3. We've got 2 kip force coming down, another length of 3. We have BY, which we don't know. We have 2 kips over here. And then we have that pin over here, which we don't know much about. So we're going to say AY and AX. First off, looking at this, how many forces do you see going in the X direction? Well, there's only 2 forces going in the X direction. One of them you don't know. So boom! What I see is sum of the forces in the X is equal to AX minus 2 equals 0. So AX equals 2. Wonderful. Okay. So I have solved for that. That's 2. I've got 2 more equations. I have 2 more unknowns. I should be able to solve for this. Now, as a note, what you can see here is that this is completely symmetric. The distance to both of these is the same. We have force in the middle. I've got the same horizontal forces on both sides, which means that AY and BY are going to be equal to each other. But I'm not going to have you just take my word for it. You'll see that soon. So let's do some of the moments around point A. Just use our normal equations. So some of the moments at point A will be equal to, okay, clockwise is positive this time, so 2 times 3 minus BY times 6. And that's it. This 2 kip load right here points straight through A and doesn't have a moment for the component. And so if I solve this, what I get is that BY is equal to 1. Okay, so now I've got BY solved. That's 1. And now I'm going to do my last equation, which is sum of the forces in the Y direction. It's going to be equal to AY plus 1 minus 2. Very simple math here. AY equals 1. And I have solved for it. Okay, so now let's erase some stuff here. I know what BY is. It is 1. I know what AY and AX are. They're going to be 2 and 1. So all that's left now to solve for is CY. What is CY? Well, I never used my third equation from this full free-body diagram. I really don't want to have to mess around with this dude. So I'm just going to look at my full free-body diagram again and take some of the forces in the Y direction. So sum of the forces in the Y is going to be equal to BY plus CY minus 2 minus the vertical component of 4, which is going to be 6 over 10. So 4 times 6 over 10 is equal to 0. I already know that BY is equal to 1. So what do I get? I get that CY is going to be 2 plus 4 times 6 divided by 10, and then minus 1, which comes out to be 3.4 kilonewtons. 3.4 kilonewtons. Okay. And that looks pretty good to me. Let's make sure that my math is right. Yes. So CY equals 3.4. Oh, not kilonewtons, sorry, kips. And with that, I have everything. I've solved for all the forces in my system. Okay, so I hope this helps you. Just walking through the steps. It's your equations of equilibrium over and over again. It's breaking things into components. And it's making sure that you use what's given to you, like the geometry, to figure out those slope triangles if you're not given angles. So thank you for listening, and I'll see you all next time. Goodbye.